Dear students, welcome to this session. This session we will look into the module 5, and we will the module 5 is about three-phase synchronous generator. So we will see what is a three-phase synchronous generator, and the three-phase synchronous generator is also called as an alternator, and it is also known as AC generator. So you should be familiar with any of these three terminologies. So it is called as three-phase synchronous generator or alternator, and also it is called as a AC generator. As you are already aware, three phase, we talked about the single phase and the three phase. This particular generator is going to generate a three phase power. In this module, what we are going to look is what is a three phase synchronous generator, principle of operation, construction of three-phase synchronous generator, how the construction is done. First we will understand what is this three-phase synchronous generator, then we will see what is the principle of operation, how the generator works, what is the principle behind it, then we will see how the construction of the generator is done. So the construction is very important, how the construction is done for the synchronous generator, and there is some terminology known as synchronous speed. We will understand what is that synchronous speed. Then we will see what is the frequency of the generated voltage. So this particular AC generator or the alternator or three-phase synchronous generator is going to generate a voltage, and it is alternating. Whenever we have a alternating quantities, we will have a frequency associated with that. So we will derive the equation for the frequency. Then we will derive a EMF equation. Basically this EMF equation will tell us how much voltage is generated in terms of other quantities. So we can for a particular design, we will know how much EMF will be generated by that particular generator. That derivation we are going to do, and we will learn about the concept of the winding factor. So we are going to use the winding on the armature and the field. So that winding factor, we will learn about the winding factor. Problems based on the three-phase synchronous generator. So this is the topics that are going to be covered. First, what is a three-phase synchronous generator? So henceforth I will be using the terminology synchronous generator. So you should be aware, three-phase synchronous generator is also called as alternator, or it can be called as a AC generator. So henceforth I will use the synchronous generator. First thing, what is the synchronous generator? As we know, a three-phase synchronous generator, it is a machine, okay, a machine, electrical machine, which converts the mechanical energy into a three-phase AC electrical energy. That is the three-phase synchronous generator. So what is the generator will do? It will convert the mechanical energy, whatever the mechanical energy, it will convert it into a three-phase electrical energy. So in the picture you can see this is the diagram of the alternator or the synchronous generator, where you can see this is the outer part, this is called as the stator. We will see the construction in detail. This is the stator, and inside we have a rotating part, that is called as a rotor, and on this stator we have the three-phase winding. So that three-phase winding, when we rotate this magnet, this is the rotating part, so it will have a magnetic field. This part will be rotated using the mechanical energy. And how we get the mechanical energy? It depends on the what kind of power plant we have, whether it is a hydro power plant, it is a thermal power plant, nuclear power plant. What we are going to do is, in case of, let's say it's a hydro power plant, the potential energy of the water that is used to make the turbine to rotate, so it will cause the mechanical motion. Those turbines are connected to the rotor. So in turn this magnetic field system will start rotating, and the field the armature winding that is on the stator will start experiencing the change in the magnetic flux, and that is how we are going to generate the power in the armature winding. So that is the basics. So we'll see the in the construction and in the principal operation how that is going to happen. Now in majority of the today's generation, that is done using the synchronous generator. So predominantly all the generation that is taking place in this world is done by the synchronous generator. These are the most popular machines, generators that are used currently. Principle of operation. So what is the principle the synchronous generator works on? The synchronous generator works on the fundamental principle of electromagnetic induction. That is, when a flux linked with a coil or a conductor changes, an EMF is generated in that particular coil or a conductor. So this goes with the Faraday's law, electromagnetic induction. Whenever flux linked with a coil or a conductor changes, an EMF is induced in those coil or a conductor. That is the Faraday's first law. So the generator, synchronous generator, works on that particular principle. Always when you are studying the Faraday's laws, the first law is the one which tells how EMF is generated. If you answer how EMF is generated, that answer itself is the principle of operation. So if you ask how EMF is generated whenever there is a change in the flux, or the flux linked with a coil or a conductor changes, and EMF is induced or produced inside that particular conductor or coil. So if you answer the question how EMF induced, that answer itself is the principle of operation. And later we are going to derive the EMF equation. In that EMF equation, the second part of the Faraday's law will come. That is, the second part is how much EMF is generated. We know how EMF is generated. The answer is whenever flux linked with a coil or a conductor changes, EMF is induced. But the next question is how much EMF is induced. That is given by the Faraday's second law. How much EMF is induced? The magnitude of the EMF induced is directly proportional to the rate of change of the flux linkage. So we will see when we derive the EMF equation, that particular principle will be used. Next, construction. So construction of a synchronous generator, it has the main two parts. Synchronous generator or the alternator, it has two main parts. One is the stationary or the static part, okay, and that is called as a stator, and another is the rotating part, that is called as a rotor. So two main parts of any alternator is a stator. Stator is nothing but a stationary part. What is the meaning of stationary part? That stationary part doesn't move. So there is no moving parts, it is stationary. That part of the machine is called as a stator, and there is a rotating part in the machine. That rotating part of the machine is called as the rotor. And this rotor, there are two types of rotors that we are going to see today. One is called as a salient or projecting pole type. So salient or projecting pole type, that is one type of a rotor. Second one is the non-salient or cylindrical pole type. These are the two types of rotors. So whenever we have to explain the construction of a alternator, we have to explain what is the stator, and then we have to explain the two types of rotors, salient and non-salient. Construction stator. So this is the diagram that is taken from the electricaleasy.com. You can visit there. So there are this particular diagram is taken from there. Inside here we learned about the two main parts, stator and the rotor. What you are seeing, this outer part, okay, this outer part is called as a stator, and inside part, okay, which is mounted on the shaft. This inside part is called as a rotor. And what we have on the stator, so the stator is nothing but it is a stationary part of the machine, and it is built up with the sheet steel laminations having slot on its inner periphery. So you can see this is slots, okay, there are slots on the inner periphery. So this particular stator will have slots in the inner periphery. A three-phase winding is placed in these slots and serve as the armature winding of the alternator. Okay, the armature winding is always connected in a star, and the neutral is connected to the ground. So these stator, there is a slots here, okay, slots, if it is nothing but it can hold the winding. So on the inner periphery we will have the slots, and inside those slots we can place the windings. So windings is nothing but we can place the conductors, and those winding is called as a armature winding. So that armature winding is placed inside the stator, and this armature winding is a three-phase winding, and it is star connected, and the neutral point, that is if you remember the star connection will have like one end of all the winding is joined together, so that is the neutral point. That point is connected to the ground, and other three ends of the phase, so RYB, you can see these are the three ends of those three windings RYB. So these three windings are connected here in a star fashion, and that forms the armature winding, which is on the stationary part of the synchronous generator, and it is called as a stator. Next we will see the rotor. So there are two types of rotors. One is so here in the previous diagram, so this is just a representation. So what you are seeing is a salient, or the rotor inside could be a non-salient as well. Now next one is the inside rotor. So what kind of a rotor we can have inside? We can have a salient pole type. So salient pole type, salient is like you can say protruding or projecting. We have projecting poles, right? You can see in the diagram we have a protruding or the projecting poles. So this is the one pole, you can see this is marked as a south, another this is north, and this is again north, and this one more pole. So we can see there are four poles that is mounted on a cylindrical structure. Okay, so in this type the salient or the projecting poles are mounted on large circular steel frame. So what you are seeing is a steel frame. They are mounted on the large circular steel frame, which is fixed to the shaft of the alternator as shown in the diagram. So the center part, this particular cylindrical frame is mounted on the shaft, and on top of that cylindrical structure we have these poles fixed. The individual field pole winding are connected in series such a way that when the field winding is energized by the DC exciter, adjacent poles have a opposite polarities. What is the meaning of that is you are seeing a winding here. So the winding, this is called as a field winding. So the field winding is energized with a DC supply. This particular winding will be given with a DC supply, and this winding there is a we can start from here. The winding goes from here, so it is connected. This winding is on this pole, and the winding direction is in such a way that either it will create a north pole or the south pole. So suppose let's say this winding, let's say it is in the clockwise direction, and it will create a north pole, and the adjacent, on the adjacent pole, it would be in the anti-clockwise. The field winding will be winded in the opposite direction, anti-clockwise, so that we can get a south pole, again north pole, again south pole, and that terminal comes here. So we have one terminal here, the other terminal here. These two terminals are connected to DC supply. So this has to be we are giving the DC supply, and we are generating a magnetic field. We know that when we give the DC supply to any coil or a winding, what happens? A direct current will flow and it will create a magnetic field. So basically we are using that DC supply to create the magnetic field. Now this particular pole is a rotating, so this is a rotating part, isn't it? When it is a rotating part, how we will make a connection, how we will give the DC supply? For doing that, we use a pair of slip rings. So you can see here circular, this is one slip ring and this is another slip ring, and on that slip ring we have the brush. Okay, these are the carbon brush which will be fixed. It is not fixed, it will be just pushing on that particular slip ring, making a firm contact with that slip ring. So here one more carbon brush we have, and even this carbon brush, it is sitting on top of this particular another slip ring, and these two wires which are connected to the brush are given with the DC supply. Now what happens is when this rotor rotates, then what happens? These slip rings also rotate, but brush is in contact touch. Okay, when brush is in contact touch, that electrical current circuit will be closed one and current will flow. So basically this particular part, what you are seeing, where we have the brush and a slip ring. So the slip ring, when it rotates, this part will be rotating, but this part will be firmly pushed against that particular ring, so that it will make, even though the rotor is rotating, the carbon brush, okay, it will be pushed against that ring, and it will make a constant firm contact with the slip ring, making the electrical circuit closed. So it will not lose the connection with the slip ring. That is how we can give the supply to these two brushes, and the current, DC current will flow, and it will create a magnetic field. So that is how it creates a magnetic field, and this is the rotating part. So whatever the winding we have here, it is called as a field winding, and this field winding is excited by a DC supply. Excited means what? It is given with a DC supply. The current that is flowing in this winding is a direct current, and this direct current, when is flowing through this coil or the winding, it will produce a magnetic field. So the direction of the winding would be in such a way that it will create either a north or the south pole. That is the salient pole type of a rotor. Next one is a non-salient or the cylindrical pole type. In this, you can see here, we do not have a protruding poles, but the surface is the cylindrical. The surface is cylindrical, and in how the construction is done, we can see on the outer periphery we have the slots. So you can see here slots. These are the slots. These slots are provided so that we can have the field winding. So you can see this is the cylindrical piece. Okay, on this cylindrical piece we have slots, right? You can see the slots here. Also there are slots here, and also there are slots here. Inside these slots, what we do is we put the field winding. So we will put the field winding, and all these field windings are connected in series. So everything is connected in series, and that is connected to these two slip rings. Okay, you can see the two slip rings here, which is mounted on the shaft. Inner one is the shaft. They are connected to these slip rings, and to these two slip rings we have the carbon brushes, which are which make a firm contact with the particular slip rings, and those to those brushes we connect the DC supply. So when we give the DC supply, the current will flow through the slip ring, through the conductors, all the conductor, these windings, and back through the another terminal. So this will create a magnetic field in a such a way that we will have a alternating north south poles. So this particular type of a construction is called as a non-salient or a cylindrical type. Now we will go back here. The construction of a salient pole. The salient poles rotors are normally used for the low or the medium speed, because if you see mechanically the structure is not very robust. We have cylindrical structure, on top of that the poles are mounted, so it is mechanically not robust. This particular type of a salient type of a rotors are used for the low or the medium speed, that could be in the range of 120 to 400 rpm. As low speed rotors are there, these are having because these are low speed, they will be having a large diameter. The diameter would be large, and the length, if you see this kind of a alternator, you will see the diameter is very large, but the length is very small. And the salient pole construction, it cannot be made strong enough to withstand the mechanical stress for higher speed because of its construction. On the other hand, the non-salient, you can see it is a whole cylindrical structure. The winding is well inside that cylindrical structure. This looks mechanically robust. So non-salient pole rotors are used for high speed alternators. So what is the range of the high speed that is used is around 1500 to 3000 rpm. These rotors are if you see these kind of alternators, their diameter will be small, but the length of the machine would be axial length would be more. And this kind of a alternator using the non-salient pole type, since it is mechanically robust, and it can give almost a noiseless operation even at the high speed. Now the next diagram, just to make understand the previous things, you can see here, this is the diagram. Basically it will tell about all the parts. So if you see the first diagram, I will go back to the first diagram. Okay, in this diagram you can see there are different parts. So we have, starting from the if we start from the innermost, we have shaft, slip rings, two slip rings. On top of the slip rings we have brush, okay, and that brush is connected to DC supply. And we have this salient type rotor, and we have the field winding. So this is a salient type of pole, and this is the air gap, and outside this we have the armature, that is the stator, and inside the stator we have the armature winding. So you will see this is the diagram which just shows every part. Okay, you have to just imagine the every part is shown how it will fit. You can see here, this is the innermost part, that is a rotor. So you can see it is a cylindrical structure. This one it looks like a non-salient cylindrical type, and we have windings inside, and on top of that we will have the slip rings as well. And this structure goes inside this. This is a stator, and inside the stator on the inner periphery we have the armature winding. Okay, and this goes inside this, and both of these gets inside the front bracket and the rear bracket. So this will be in the outer frame, and it will be mounted on these pulleys. So you will have the shaft will be mounted on the some kind of a bearing, so that it will give a easy motion. And on the end where we have the slip rings, we will have the brush holder. So this brush holder will come on top of the slip ring. You can see the brush holder. So this is how it will look in the real world. That is how this is constructed. So for the just to summarize, we understood what is the alternator, what is the principle of operation of a alternator, and how the construction is done, what are the main parts, what are the different types of rotors of the alternating three-phase synchronous generator or the alternator.